Alright, this is a video number 4, a series for the introduction of DORM, Dry Object Relational Mapper, whatever. The name is temporary. I can switch it to something else. And the previous video, we were just going through this example of the query builder and looking at how it builds the queries from multiple components. As you recall, the query are consisting of chunks of expressions, and what's specific about the expression is that it separates the template from the parameters, and then it all can render all together as the final query. So let's see here if there is anything interesting. 6 alpha deployments, just adding more joins. This is a real life scenario where so they're passing the identifier there. This wrap up this. Okay, and this is where we're starting doing the width. The width is pretty interesting. That's the final query that we're going to be building. Okay, so this is a smaller portion of it. So we generate a query just to generate a series. Here, a new thing. So that's expression arc function. So this is similar to creating an expression. However, we define a function name and parameters. Yeah, so all the parameters are expressions, as you would expect. The function name is a string, so it will not be quoted. And once again, we render that. We put the expression inside the query, so it would be like select from generate query, generate series. That's what it is, right? Yeah, select from generate series, yes. Then we have another query here, so that's a time series query. Join from a table time series. Yeah, so the table is defined inside the width block, but it's not being done in here, but rather in the final query. Yeah, so we're adding it to width blocks, which is time series and daily deploys, but daily deploys relies on time series. Well, that's how I suppose SQL works. So there should be no issues with that. And we are querying from daily deploys, just defining again columns. We want to get it and group by, order by. Once again, expression here. This can be called multiple times, so that's it's going to store very similar to ATK data, to be honest. Okay, let's run that. Let's run this query builder, see what kind of query it will generate. And there you go, that's the query. So actually there are a few queries. The first one generated is that. Puts a couple of extra parentheses around expressions here. Yeah, so that's expression. We want to be careful about that, so yeah, it's cool. The expressions were not surrounded in parentheses when we were using them, so this is just when we use it as a field. That's where the expressions get, and I think it has to do something with or, and I believe also when it's used inside the conditions. Right, so it would also be surrounded in additional queries. But yeah, this is a proper query that actually I believe that works properly. And as you can see, the values like 7 and these things are all being properly matched into the query inserted. Okay, so this is pretty good. So this is actually a pretty complicated report, and it's just being translated into the series of queries, so they can go into the separate function, I would suppose, and can rely on each other, and they do offer a little bit of better understanding. So some of the things can be parameterized, so you can just feed these things into the functions, and then it generates your query. Okay, so expressions we're done, queries we're done. Let me just show you one interesting concept before we go into the tables, right? So table, as you know, it consists of fields, right? But field, it can also exist on its own. So in my example here, let's say name equals field, right? And then new field, this is expected to be a string. Okay, and alias is optional, so it will be sum, right? So it could be either sum or it could be none. Actually, let me just say it's none to clean this up. All right, so this represents a field called name, and it doesn't have an alias. We could do render chunk on the name, right? So name render chunk, right? Because it's an expression, like a, and it generates an expression which we can do preview, right? So we already know that. Okay, and we have name, right? So that's just the field. So if we do have alias, some and to string. Oh, what is this? Yeah. So interestingly, when we have the field, whether or not it has the alias doesn't matter. Although the logic should probably use the alias if we have an alias. Yeah, so that's a bug. Because we can use fields in various locations. For example, when we're joining something with reference field, and it's a type of field, right? And next thing, what I wanted to show, name, it implements another trait which is called like a condition here. It's called AQ, and there we specify another thing. So let's try and do 1, 2, 3. Probably it needs to be like that. Condition, right? So now we have made a condition, and let's render that. Let's see. Okay, and so this renders to name equals 1, 2, 3. And that being can also be string. Maybe not. Should be possible to. Okay, it doesn't want the expression, wants a reference to expression. Okay, so name equals test. But in test to string, and then we pass only reference to that. Yeah, you see the difference? So if we saying that the name equals expression, and the expression just renders without the quotation marks, but if it's a string, then there are quotation marks. What else? We could just do like a surname. So this will be surname. And I could do name equals surname, right? So this should work, right? Name equals surname, and we have like a type safety. And this is also a pretty nice way of how you can create these conditions. Now there is also and condition, right? So let's do larger than, and put it here. Tables like this. It's a little bit messy at the moment. It might have been expression or. Where do we have or? For some reason. What is implemented for conditions? Yeah, it should have been fine. With the condition. Oh, right. Yeah, so it works like this. Name equals or that thing. So this is how it changes, right? So we can probably add more. And here we go, right? So it's that or that. So either name equals surname or name is less than surname. That's the syntactic sugar. So this is a bug that it doesn't like this one gets the value by reference, but this one doesn't. So that's just a bug in the code. More operations will be implemented later on. For now, it's just a few. Anyway, so I just wanted to show how this condition operates. And next, let's think. So we've got fields, we have conditions. I'm just going to give a basic introduction on the table. Let's users equals. Right, so this is how it rolls. Doesn't want a string. And then as a data source, we need to have Postgres. Okay. So this is where the association with a data source comes in. I'm just going to use this another example to show how to set this up. So we'll just take this block, copy into our example cleanup, and then talk a bit about it. Right. So that's not needed. Okay. This needs. So this is the standard boilerplate initialization of the Postgres connection. I'm not going to go too deep into that. It's implemented in a crate called Tokyo Postgres, and it's an async connection. So it spawns a separate thread, and the thread is the one that interacts with the database, and it allows our code to be non-blocking, so we can execute a query. We don't have to wait for the query results. And in here, we are going to put the client into a box, an arc, and we're going to create a Postgres, which is what we call as a data source. So this is like a layer between the third-party implementation of the client, in this case, this is data as the client, right? And the Postgres is the data source from Dorm, which designed to work with the Postgres. And then we can do certain things in here. And so for now, let me clean this out. Return back println world, and make sure we still can run. Okay, just a few things here. So we changed our main FN function into async, which means it now can do things like spawning threads and stuff. And this isn't necessarily macro. The Tokyo is a crate that implements parallel execution environment with async blocks. We'll call it async runtime. Okay, not going to go into that. And then finally, we have result, which allows a certain code in here to fail. So you can think about it as a code that can potentially throw an exception, right? Except that there are no exceptions in Rust, but a function can return enum, which is either like nothing here, okay, just empty with nothing, or things like that can potentially generate errors, these question marks. Essentially what it says, if this fails, throw the error by returning a result of R, like this one. Now that's kind of another way of doing that. Okay, so I'm gonna wrap up this video, and next video we're gonna talk about tables.